Alright. We gotta get started right now because the SpaceX launch is happening right now, so we gotta speed run. Hello, Speeding at Sea, it's me, Z. Today we are really speeding because I did start stream a little bit late, and also there is a launch happening right now, which we'll be able to catch. So let's watch. T-4 minutes, I think.
And you can see that the clamp arms are fully open and that TE is starting to move away. It's very slow and slight.
Oh no. Oh, okay, we're all good. Thank you so much to Sharks for
connecting from the TE to the vehicle. At liftoff, that will disconnect.
Stage 1 LOX load is complete.
And good call out there. Stage 1 LOX load is now complete. Stage 2 LOX load will complete at the T-2.
Can you guys hear that? So this is one of the SpaceX launches. Huge shout out to Sharks for letting me know about this launch, and so glad that we're able to catch it.
We are still loading liquid oxygen on the second stage, but once that concludes at the T-2 minute mark, that will conclude propellant loading for Falcon 9.
So this is actually for STARSHIELD, I believe, which is sort of a next generation spy satellite from the U.S. National Reconnaissance Office.
Liquid oxygen loading completion on stage 2. Once that concludes, we will begin to vent out those propellant lines. And you may see a few more white clouds coming when that happens.
Ooh. Yeah, so this is actually being launched from Vandenberg right now. And it is actually the 4th launch supporting the National Reconnaissance Office's proliferated architecture, which is
for that call out for liquid oxygen loading on second stage.
So this is a constellation of small satellites for quote-unquote capability and resilience.
And there's that call out that we were waiting for. Now that
okay.
loading is complete on the second stage, again, this concludes propellant loading on Falcon 9. And you can hear and see that those white clouds on your screen coming from the TE. That is us venting out the propellant lines. That really cold liquid oxygen gas coming in contact with the warmer ambient air is what's causing that condensation that you see there on your screen.
Yes, so definitely go check it out. This is so hype. Oh my god, only 1 minute left. We really caught it at the perfect timing.
Great call out. Falcon 9 is in startup. The internal flight computers have now taken control over the countdown. Just waiting for the final go from the launch director.
SpaceX launch director, go for launch.
And great news, we are go for launch.
Woohoo!
Let's listen and watch as Falcon 9 takes the NRO payload into space.
T-30 seconds.
30 seconds. I want to play Kerbal now too. This is giving me the sudden urge. Yes, go look up StarShield. It's super cool.
T-10.
10
9,
seconds.
8, 7, 6.
Oh, it's so loud.
5, 4, 3, 2, 1. Ignition and launch. Go.
It's like a laser in the sky. It's so loud. Lift off.
Stage 1 propulsion is over.
Wow.
T+35 seconds into launch, and Falcon 9 has
spectacular.
successfully lifted off from Space Launch Complex 4E at Vandenberg Space Force Base in California.
Nominal power and telemetry.
They're not going to catch the thing, I think.
Coming up next,
Are they?
vehicle will be passing through Max Q in a few seconds here. This is the point of...
Vehicle is supersonic.
Yes, this is perfect timing.
Experiences the greatest amount of aerodynamic pressure.
Wow, look at that view from the from Vandenberg. Look at that coast.
Max Q.
That's a beautiful view right there.
Great call out there. Now the vehicle has passed through that highest amount of structural load on the vehicle.
I wonder why the highest
Coming up
amount is
next,
just
we will have
here
a
and then
few
it falls off.
Events happening very quickly in succession. That'll be MECO, stage separation, and SES1. MECO is main engine cutoff, and that's where all 9 of those Merlin 1D engines that you see burning bright on the screen.
Started.
Yeah, I don't think it's going to be caught.
Those
yeah.
9 engines will shut down. That helps slow the vehicle down in preparation for stage separation.
Whoa, look at that
Stage
view.
separation is where the first stage and second stage separate.
Yep,
and
atmospheric
the first
pressure,
stage
yeah.
will continue to make its way back down
But,
to Earth as the second
is it
stage
just
continues
because-
with the payload to take it to its targeted drop-off orbit.
It's probably because that area of the atmosphere is relatively thick. After a certain point, the atmosphere becomes really not so dense. It would be really cool if they caught it with the chopsticks, but
MECO stage separation and SES1. SES1 is second stage engine startup 1.
wow.
That's where we'll light that MVAC engine on the second stage.
Look at that view. I think space tourism would be
And
super
as a reminder,
cool.
we will not have any views of stage 2 or the payload at the request of our customer.
Oh, that's so mysterious. They're really
Main
keeping it
engine
on the
cut
down low.
Stage separation confirmed.
Super spooky.
And back ignition.
Wow.
Beautiful views. We had MECO stage separation as well as the ignition of the second stage engine.
We're so lucky we
And
caught
now
this.
that first stage vehicle is making its way back down to Earth, and a great view there with the grid fins deploying.
Oh, let's see this. Yeah, no, the exhaust plume looks really amazing. I do want to go to space, though. I think I've been more open-minded to space tourism recently. I feel like even just, like, going up into space and then just going around the Earth once and coming back down would be really fun. Would you guys do
And you
that?
can see that the telemetry of stage 1, it has not yet reached its apogee, but once it does, it will begin to make its way back down to Earth
Fairing separation confirmed.
for landing. And good call out there that we had confirmation of fairing separation. We will be
Woohoo.
attempting to retrieve the fairing halves today once they fall back down to Earth with our recovery vessel Go Beyond in the Pacific Ocean.
Spacewalk is
Today's
scary.
fairings are flying for their 16th and 7th times
Definitely,
today.
definitely. I feel like spacewalk is a little spooky, though, because you're only isolated from the harsh environment, the vacuum from, like,
These views
a
are so
spacesuit.
great. You're looking at a view from the first stage vehicle,
Wow.
and relative to Earth, it looks very slow and calm, but the vehicle is moving very quickly. You can see the speed in the bottom left-hand corner of your screen there,
Oh no, it's blocked.
and you can see that the altitude has stopped increasing. We've just about reached apogee, and now the vehicle should begin to make its way back down to Earth.
Wow.
Again, attempting our
This is
landing
live.
today
This is
on,
live.
Of course, I Still Love You, our drone ship in the Pacific Ocean.
Oh, so the one of the parts is going to land. That's a cute name, by the way. I feel like, yes, I would take the parabolic flight. I would like to take the one where you get to be, like, floating in space for a little bit. But I assume those tickets are really expensive. Z to space would be really cool. Spacewalk or star hiking? Ooh, star
Now we're
hiking.
just about a minute away from
Star
the next
hiking.
event for the first stage. That will be the entry burn. The entry burn is where we will reignite 3 of those Merlin M1D engines. This helps slow the vehicle down as it's re-entering the Earth's atmosphere.
Wow. Yes,
And that
this is
burn
live.
should last about 20 seconds long for this mission today.
And yes, I am wearing a black
Some
hole dress
cool
for
views
Halloween.
here. This is from the first stage looking forward towards the top of the vehicle. And this is inside of the inner stage section of Falcon 9.
But I think I'd die happy if there was a mishap in space. Like, I think just knowing that I was able to go to space before, like, and experience
Just under
that would
30
be really
seconds
nice.
away from that entry burn.
Yes, and also I'm dressed up as a black hole, specifically the photo of M87 for Halloween. So this is my spooky outfit.
Such great views here today. Again, we are coming up on the entry burn for the first stage vehicle. you can see the altitude decreasing, and we'll reignite those engines to help slow the vehicle down even more.
Stage 1 entry burn startup.
It's an unspecified number of satellites, too. I'm reading a bit more about this. This is actually the 100th Falcon 9 launch.
You can visually see that the engines have ignited. Again, this burn will last about 20 seconds.
Wait, the logo for the National Reconnaissance Office is strength in numbers. Isn't that so terrifying? Sounds really
Stage 1
spooky.
entry burn shutdown.
I guess there's really little information on the launch.
There, as well as visually seeing that the engines have shut down. That concludes the entry burn for this first stage's
look at those
journey
clouds.
back to Earth. The next event will be in just under a minute from
Stage
now.
1 FTS is saved.
Yes, this is the photo
In
from
just
the
under a
Event
minute from
Horizon
now,
telescope.
We will ignite the center engine on the vehicle for the landing burn. The landing burn will last about 15 seconds long, and that helps slow the vehicle just in time to touch down again on our drone ship. Of course, I Still Love You, currently in the Pacific Ocean.
That's such a sick name, by the way. So apparently these satellites will basically diversify communication pathways and enhance resilience.
And we do only use
hundreds
one
of small
single engine
satellites.
for that landing
Stage
burn.
1 transonic.
Stage
Ooh,
2
it's
FTS
landing!
is saved.
This is so hype.
Each of these engines has 190,000 pounds of thrust, again, just enough to slow down the vehicle. We are currently using the drag from the atmosphere to help slow down the vehicle, and you can see the speed dropping, again,
300
bottom left-hand of
total
your
is
screen,
crazy.
that it's drastically dropping as we're getting closer and closer to Earth on the first stage.
I feel like SpaceX is really increasing the accessibility of just going to
Stage 1
space.
landing burn.
300 is
That
crazy.
call-out landing burn has begun. Let's watch as Falcon 9 touches down, and of course, I Still Love You.
This is spectacular. I feel like this never gets old. This is absolutely amazing how they're able to... Look at that!
Landing light deploy.
Oh my god, look at that! Isn't that
Stage 1
amazing?
landing confirmed.
And
Wow.
great views there. Falcon
Wow.
9 has touched down on, of course, I Still Love You. This was the 21st launch and landing for
Dang.
this booster. This
Wow.
landing marks SpaceX's 358th recovery of an orbital class rocket, including the first stage landings for Falcon 9 and Falcon Heavy. Today's mission
And
marked
back shutdown.
Today's
That was
mission marks
so clean.
SpaceX's 396th overall mission to date and 101st mission of 2024.
Wow, that was
As a
spectacular. That was
reminder, we will
clean.
not be showing any stage 2 or deployment views at the request of our customer. So with that landing of the Falcon 9 booster, we'll be bringing today's webcast to a close. Thank you to the National
Yay!
Reconnaissance Office for entrusting us with today's mission.
So that was the launch. That was so classy. Wow, no, that was spectacular. Wow. I feel like that landing never gets old. So I was sort of looking at some information about this launch, and a lot of it is secretive. But from what it seems like, these satellites are believed, this is from a Spaceflight Now article, by the way. These satellites are believed to be the STARSHIELD satellites manufactured by SpaceX with cooperation from Northrop Grumman. In a recent job listing, SpaceX noted the distinction. So basically, StarShield uses SpaceX's Starlink technology for national security efforts. So it has a focus on Earth observation, communications, and hosted payloads. Basically, this is the spy satellite program that people have been talking about. But before you go crazy and say this is all bad, I have heard of actually uses of spy satellites being really important. Whether that's for like agricultural development, weather tracking, and more. So basically a ton of satellites. And thank you so much to Handful of Sharks for telling me about this launch. And I'm so glad we were able to catch it and literally see the rocket land. If you guys have any other launches that are coming up, please don't hesitate to DM me on Discord. The Discord channel should be linked here. And yes, please let me know if you see any launches that you'd like me to spectate. This is super cool. Let's see. Ultra secret alien technology, exactly. Woohoo! Boop. Now let me scooch this over. Yes, so back to our original schedule. So today is our super exciting Q&A stream. Thank you guys so much for submitting all of your questions, and this is basically in celebration for the 1,000 subscribers. So I wanted to do a Q&A and just like catch up and also do a bit of learning. So we have about like 36-ish questions to go through. So we'll have to speed run through all of them. So I'm starting off with the fun questions first. But wow, that satellite launch was really exciting. Yes, thank you so much to Sharks for posting the links and information. I'm pretty sure Sharks knows more about this than I do. But this is super duper duper cool. Yes, and yes, I do have a stream elements. I think if you do ! commands, you can actually see all of the commands that you can do. Anywho, it's a time to get started. First of all, let's do roll call. I'll just go through my chat list. Hello, PogChamp Senpai. Hello, Sharks. Thank you again. Hello, Eggy. Hello, Germanium. Hello, Mind Force. Hello, Sonoda. Hello, Faving. Hello, John Doe. Thank you. Yes, this is my new black hole outfit. So for Halloween, I'm dressed up as the Event Horizon Telescope's image of M87, which is an active black hole. This is one of my favorite photos because it really was a worldwide effort. In order to get this photo, they basically had to construct an Earth-sized telescope. So the way that they did that was that they had telescopes at different sides of the Earth and were able to stitch together and combine the images to get a really crisp photo of the black hole. So it's really a demonstration of collaboration, and also it just looks super sick. Hello, Astral Atropos. Hello, Kaito NASA. That's such a cool last name. Hello, Kai87. Yes. No, this is great. I have to say though, this is not exactly my 1,000 sub celebration stream. That will actually be this Saturday, where I'll be building an amazing Lego set. Huge thank you to Panzerfan for getting me this Lego set on my Throne account. It's a Lego set of the Earth, Moon, and Sun revolving around each other. And I think it actually is the perfect ratio. So if you like turn the Earth, like the rotation happens along the Moon and the Sun. It will be super cool. I actually haven't gotten a chance to look at it very carefully yet. And I'm also unboxing a brand new mouse pad as well, which will be super hype. Yeah, no, how important was the geography trip? No, the geography of Iceland is gorgeous, but if you've never been to Greenland, Greenland's pretty sick too. Hello, Okami Race. All right, without much further ado, how about we get started? How is everybody doing today? I'm going to drink some water. Yes, wait, Eggy, you're so right. I could make a Syzygy with the Legos. I mean, this is the perfect Lego set because it is all about Syzygies, right? And for those of you who don't know what my name really means, it's not only an epic word with no actual vowels, but it's super cool because the idea of a syzygy is when three objects are in line with each other. So that can include things like planets. An eclipse is an example of a syzygy, or even the occultation of planets and so forth. So yes, this is the Zlego, the Zego. I'm so excited for the handcam stream. I also got a mouse pad that was gifted as well, so I'm excited to unbox that as well. It'll be a very cute addition to my currently empty table. Whew. So for the past few days, I've been really swamped with work. Almost to the point that I actually considered not doing today's stream, but I'm really glad that things worked out really nicely. But for the past few days, I've been pulling late nights and waking up early and drinking coffee. And I know I have a coffee addiction, but I think it's been getting to the point where I've been getting headaches after I drink coffee. I don't know if anybody knows why that happens. I'm wondering if it's some sort of dehydration. But I have to be really cautious with my coffee intake. So for the past day or so, I've been not drinking coffee to try to see if I can cure myself. I didn't realize Syzygy was actually a word. Yeah, no, it's like one of my favorite words. If you ever play Hangman, nobody will be able to guess it because there's so many random letters in it. Yeah, no, it constricts your veins. Yeah, I thought like coffee helps like increase blood flow, but I've been getting really bad headaches along with pulling really bad late nights has not been a good combination. Anywho, be careful with coffee. Be very, very careful. Let's get started with the questions. Yeah, maybe we'll have to ask Faye. Actually, let me jot that down. Let me ask Faye, why coffee? Speaking of, thank you guys so much for coming to the stream. Back to work for me, I'm here listening, but just not in chat. No worries, thank you so much for visiting and for letting me know about the launch. So thank you guys so much also for visiting my stream with Faye. It was so much fun. And Faye was one of the first science VTubers that I actually encountered and was really helpful on getting me started on my VTubing journey. I think I really just found her in my YouTube recommended, which is crazy. We've been chatting about a whole bunch of ideas. Toy and bee idea. Thank you so much for joining the orbeez. Yeah, and we've been already thinking about maybe doing another collab or maybe, hopefully, fingers crossed, even doing an off collab. I think that's the one where you like meet in real life, right? Off stream collab? Off collab? I think it's just called an off collab or something. Which would be super cool. Maybe we'll be able to cook up a concoction of prions and whatnot. Anyways, if you haven't already, go subscribe to Faye as well. She is absolutely amazing. YouTube has good taste. I need the YouTube algorithm to work in my favor. Anywho, we have so many questions to go through today, so let's get started. Whoop. Okay, first question. What is your MBTI? I'm actually curious. Class, if you could let me know what your MBTI is as well. I'm actually curious to see what the mixture is. I feel like people who are more science-leaning also tend to have specific MBTIs. Well, I am ENTP, which is the debater, I believe, on the MBTI, like 16 personalities chart. So MBTI is a list of like 16 personalities. It describes your like characteristics for each letter. So I'm ENTP, so the E stands for like extroverted, which is probably pretty obvious from now, not gonna lie. N is like intuition, and then like T, what is T? It's like F is like feeling versus like objectiveness, and then P. I actually don't know what the letters stand for. Actually, let me quickly look this up. MBTI meaning. Let's look this up. Okay. So E is, so you can have E or I, which is extrovert or introvert. So the second letter is S or N. So I'm N, which is intuition, and S is sensing, how a person takes in information. T and F is thinking / feeling. So how a person makes decisions. I'm definitely more thinking. And P and J is judging or perceiving, how a person approaches the outside world. Judging? What does that even mean? Anyways, it's a really fun way to sort of compare MBTIs, and there's like certain MBTIs which are compatible with others, and certain like jobs for MBTIs which match well. ENTJ, we're very close. I think that one's the commander. INFP. The really funny thing is, sometimes when I'm feeling really tired, I can be more of like an INFJ, I think. I think it really switches off. This is why it's really good to take the test more than once, because what I realized is that your MBTI switches based off of like your current mood and how you're feeling. Maybe if you took the test after going out all night and feeling like really socially drained, you'd get more of an I or a J. And then if you're really well rested and you're ready to socialize, you'd get like more ENTP type stuff. They say I'm INTJ. Ooh. I think, the E and I is really in between. I think nowadays there's this term called like being an ambivert, which has been on the rise, which is sort of like being a mixture of both. And I actually feel like that encapsulates a lot of people and is actually more advantageous. because you're able to sort of connect better with a broader populace and sort of adjust yourself based off of like the vibes that you're getting. There's actually, I think, like a whole book or reading on like why being an ambivert is so good, and not just being constrained to one or the other. But anywho, that is my MBTI. Okay, next question. Alternate career if you didn't do physics. I honestly feel like maybe I would do more aerospace engineering. But I think, isn't that mostly physics? There's a lot of computational physics modeling, a lot of engineering physics within it. If I had to stay fully away from STEM, I think it would honestly be really cool to be a chef at a Michelin star restaurant and like go to culinary school and like express myself through food, because I really do love food. What about you all? I do know that many of you come from like very, very different backgrounds. Or maybe your alternate career would be physics. Isn't that just physics? Honestly, I think the really cool part about physics is that it really encapsulates everything. There's nothing that's just like not physics. Cooking can get really sciencey. I think even chemistry would be really cool. Although I have to admit that in high school, I was not very good at chemistry. I think chefing is really cool. Aerospace engineering is mostly PowerPoint engineering. Wait, but I think that's low-key kind of fun. I feel like giving presentations is one of my favorite things to do. I love giving presentations. Slideshows are so fun. At least it's not like Excel spreadsheets, right? Ooh, philosophy papers. That would be so cool. No, that would be actually really fun. I think philosophy, though, really requires a specific type of brain. It's a type of brain that I want to personally foster. I think also it would be really fun to be like one of those like motivational speakers, or like somebody who runs a gym and is like, yeah, go, 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 and like encouraging you to like work out harder, just like one more set. I think that would be a really fun lifestyle too. Although I feel like it would be a little competitive. Okay, next question. Integrals gang or derivative gang? Integrals, 1000%. No question at all. I love integrals. I'm actually curious. Integrals or derivatives? I want to see what you orbeez think. Integrals or derivatives? I feel like there's just something so fun about the integral symbol. Just thinking about integrals. I mean, there's even like integral Olympiads, which are so cool. Boring business, I was very good at, but I don't have the process. Oh, like the Boring Company made by SPACEX? I mean, Elon Musk. I feel like doing a startup would be cool too. Though I feel like you have to have a certain kind of mindset and a lot of patience for it. I feel like even academia is a lot of patience though, right? Okay, next question. Derivatives are in the lead. Orbeez, I just have to say, I think the people who voted for derivatives will have to be ejected from the classroom. Differentiating team, Eggy, all career. Oh no, Eggy, you're already a pro at Tea Master. I don't think that even has to be an alternate career. That is your like side hustle. Aeronautics school, but didn't finish. Oh, but I feel like aeronautics school is really, that's super cool. I think it's really cool just thinking about like space missions, and like building things that will go out there, or like making something and knowing that it's out there in space. Derivatives all the way. But in derivatives, you don't have to think about like plus c, which is like super fun, like adding the constant to the end of the integral. Okay, well, we have a lot of questions and maybe even less than an hour, so we'll have to zoom through these. How many stuffed animals do I own? I'm looking around my room right now and I can already see about like 20. I have a really weird mixture. I have an Among Us plushie. I also have the Shy plushie next to me right now, which was gifted to me on Throne by Tika. Thank you so much. I think we named the Shy Zybe or Canis Minor or Canis Major. crocheted a long Among Us. I might need to take a photo of this. It's an Among Us, but it looks super, super long. I also have a Furby plushie, but it was like, I bought it for over $100. It was like broken and recrafted to become a long Furby. And when I mean long, it's like huge. It's like a snake. I should take a photo of this later if you guys want to see it. My cursed plushies. Of course, I have an Among Us plush. I wouldn't be Z if it wasn't for Among Us, right? Integrals because quantum mechanics and particle physics. Yeah, no, I feel like I interact with a lot of integrals through that. It's actually half-half now. We'll need somebody to break the tiebreaker, actually. It's exactly 14 votes. I'll have to take a photo of my plushies. Okay. Next question. Biggest gamer moment. I have to admit, it was my most recent YouTube short. It was the one where I like magically got the soda can into the trash bin in Superliminal, like without even looking, which was crazy. I was actually so shook. Aw, who voted for derivatives? Now derivatives is in the lead. No! You can't do that to me, Orbeez. You can't do that to me. Okay, next question. We're speeding through these because we have a lot of scientific questions later on that will take a long time to address. What hardware and software do you use for your model? I use OpenLive 3D for tracking, though I'm thinking about switching it up because there's a bit of lag between what's in OBS. For hardware, I guess I have a Razer microphone and I just use my Mac. It's like a MacBook Pro, I think. So really simple hardware. I really want to spend more money on getting better hardware. Oh, I also have like another monitor which I use for streaming. Yeah, now it's tied again. Whoever votes for integrals next will get a shout out from me. You'll get a round of applause. Yeah, so that's... I'm planning to switch things up, hopefully. I think it would be really cool to also get like a gaming PC. Because I am using a Mac. But even with a gaming PC, I can still play games. Here's a hint. I think on Halloween, or maybe the day after, I'll be doing a spooky game. I think you might be able to figure out what it might be, but you might be able to guess. Very TBD. You were very lucky to see my pro gaming move. Yep. Hello, Mino Rick. Okay. So I received 2 questions. When is the magnetic violin cover coming out? When are you releasing your cover of Ailight's Magnetic? So a lot of people loved my violin cover. Thank you so, so much. So the reason why I haven't been able to do a violin stream or violin cover recently is because I left my violin. So I usually leave my violin like somewhere else that is not my current residence. So I don't have access to my violin right now. I could easily rent one, though I feel like my violin it's really old and it's really nice and it sounds really good and it's sort of like my child. So I feel like I'd be like cheating on it if I don't use that violin. I also feel like I'm also used to the shape and the hold of the violin, and like the, how do I say it, like the friction of the bow against the strings. It's just like all these little factors. So I'm waiting till I come back and get the violin. So maybe over Thanksgiving, I might be able to record a cover. Who knows? That might be a mystery. I think when we hit a major milestone, we should do the violin concert, which would be super cool. Also, derivatives is in the lead again. Okay, I think that has to be the conclusion. Yeah. Orbeez, such a disappointment. That just means that next time maybe on the whiteboard we should do derivatives instead of integrals. Yeah, it's like the soul of what I play. Exactly, it's like my child. Maybe I should do a derivative stream where I just solve derivatives. Friction is negligible. Actually, if friction were negligible, I wouldn't even be able to play the violin. But But yeah, that's the reason why I haven't done a violin cover yet. But in the near future, I promise. Okay, this is the question from Mino. What led you to start this channel? What were your expectations at the start of this journey? And finally, how do you feel now seeing how this project is proceeding? Okay, so what led me to start this channel? So I sort of started this channel on a whim. I was really interested in VTubing during COVID. I loved watching Hololive. Hololive Myth was my favorite. My favorite character was Ame. Although she has unfortunately left. But maybe back soon. Potentially. And I was thinking about ways to sort of help do scientific communication. And I was really uncertain on starting this because, you know, VTubing, the stereotype of VTubing is that it's games, lots of like anime culture, maybe even some sus culture. And I sort of wanted to use this as like an avenue for science, which felt really new and different at the time. So I'd say like my what led me to start the channel was my passion for like scientific communication and like hopefully using my skills to teach others. My expectations were a little low because I was a little worried about sort of how my content would be perceived. And right now I feel better than ever. I've really found there is such a strong science VTubing community. That includes like my friends Faye and CL, who is a coding VTuber. But also there's like a whole group of science VTubers from VTheorem, which includes like Phi, Syzygy, and Nep, who all do science content. So Phi does like stuff on immune systems, biology. Syzygy is a psychology VTuber, and Nep does a mixture of like fun and also like plant, like botany streaming. So if anything, it has been really, really nice finding this strong community of science VTubers. And we're all so close, and feeling that support is just really immense. So I have to say that things are amazing. I have to admit though that there are a little bit of challenges, including the fact that I am doing this part-time, and balancing this with my in real life has been a bit of a challenge. And I think I talked about that with Pembu on his anniversary stream yesterday. But I think that's the kind of thing that takes an adjustment period. And so, yeah, no, things are definitely looking up. So thank you for this question. I feel like it's good to look back. Which field of physics is your favorite? If you haven't been able to tell already, definitely astrophysics. I just love space. It's like the biggest, largest thing that you can study. Like everything is within the universe, and everything is bounded by the universe. For example, like if a vacuum decay bubble were to like approach us at the speed of light and immediately consume us, astrophysics would not exist. It's like bounded by the universe itself. Oh my god, hello Jovia. Is that how to pronounce your name? If you haven't already, go subscribe to Jovia. So Jovia is a new science VTuber, I believe. She will do like CS content, and I think a bit of like even engineering physics. And honestly, the more the merrier, right? The more science VTubers, the merrier. Jovia, actually, I'm wondering what kind of content you do. And, you know, thank you so much for asking the question, too. Super cool to explore. Yeah, it's like the adjective for Jupiter. It's like the Jovian systems. It's so cool. Yeah. I think computer science or computational physics. Okay, I have to say that computational physics might be my favorite field. I think, to be specific, my favorite field is computational astrophysics. Okay, in the meantime, let's answer the next question. Do you want to someday visit the LHC? This is actually a bit of a trick question because I've actually already visited the LHC. I visited the Large Hadron Collider last summer, so actually right before, maybe a few months before I started VTubing. I got the chance to visit this like muon detector project that they're working on. And what else? What else was there? I also got the chance to see parts of the CMS, the compact movement solenoid, which was super duper duper sick. During that time though, the LHC was operating, so I wasn't able to actually like go downstairs and see like the tubes that the particles travel through. But it was super cool. I also got the chance to talk to a lot of scientists and a lot of interns who were there. So it was a great experience. And a lot of people were there because I think the following week, they were going to have some sort of training session for new physicists joining the LHC. So it was just a great vibe overall. Oh yeah, Jovia says math, computer science, and languages. That's so cool. Yeah, so definitely go check out her channel if you haven't already. Super duper cool. Actually, maybe this is a good collab idea. Hehe. Yeah, no, it was super cool. If you haven't already, it would be great to visit. Although I have to admit that there isn't that much in the area. I went to like Geneva really quick, but yeah. I feel like there's not that much in the area, but if you take a train, you could go to some really cool places in like Switzerland. I've been doing computational astrophysics, math physics class, and it's so fun. Ooh, what kind of projects are you working on? I feel like that's always a lot of fun. It's really cool, like, translating CS results to something that's, like, physically or even astrophysically meaningful. Super cool stuff. Next question. I think this is actually the last question in the fun category, which is perfect because we will need the full 40 minutes to go through all of these super, super advanced science-y questions coming up ahead. So, do you think Maxwell deserves more love? I think Maxwell already has a lot of love, no? If the person who asked this question is in the chat, please let me know. So I think Maxwell has like the Maxwell equations, but I think people really underestimate the beauty of the Maxwell equations. He was able to basically combine electricity and magnetism, these concepts that were once believed to be separate, and like bring them together. And also in a way that connects like relativity as well. So it's really just like a beautiful intersection of all of physics. And it's one of the reasons why I enjoy physics so much, because it's able to combine all of these beautiful aspects together in a really cool way. So I think Maxwell's equations give him a lot of credit already, but I think what people don't realize is the beauty of like what exactly the equations mean and why it's so important for physics. Mainly Mathematica at the moment, for natural language, Swedish and ASL. Wow. Wait, Jovia, you know what we should do? We should learn Morse code. I've actually been trying to learn Morse code recently. I have learned all the letters. I just want to get really fluent to the point where I can be like, beep, 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 and then be able to like decipher that. So that might be super cool. That would be super cool. Mathematica is really cool too. Actually, that reminds me, one of the languages that I do want to learn, and maybe Jovia, you should do a stream on this, is learning MATLAB and Simulink. Okay, Syzygy, what does that say? HELLO. Hello! Yes, I am a pro in Morse code. But I think there's a difference between like seeing the Morse code and hearing it and being like, oh yes, that is this letter, and that letter. Yeah, no, Jovia, we should chat offline. I'm so stoked. I just love that the science VTubing community just keeps on growing. World War II telegraph VTuber? Would you guys watch that stream if I just grinded Morse code? Morse code encoder, that's so cool. I do want to learn MATLAB and Simulink though. I feel like it's a big thing in aerospace. And I have dabbled in MATLAB before, but I feel like it's just like one of those things that may prove to be useful at some point in the future. Okay, anyways, let's take a bit of a break and look at our honorable mentions. Okay, so these were sort of the questions that I did not want to answer because they are incredibly cringe. No, Jovia, you weren't interrupting the stream. I really appreciate just having more science VTubing presence. Yeah, no, MATLAB is huge in signal processing. Yeah, a lot of radar stuff. Fleeting Twilight, you're late. Well, I have to say that this is the perfect timing because we're right at sort of the middle point. And we'll have to spend the next like 20-some slides answering all of the scientific questions because there are so many of them and we have very little time because we were able to catch the super exciting SPACEX launch at the start of the stream, which will be up on VOD later on. So I don't even want to read these ones, if I have to be honest. Somebody, I think I posted this in my Discord because it caught me so off guard, but somebody asked me out, which was, okay, this is a Q&A form, not a simp request form. Somebody asked to call Chad Degenerate Matter, but I think class is already a cute nickname, no? I don't know if you guys have seen, but people are saying that, like, chat is actually the first, like, fourth person pronoun. Because, like, when you say chat, like, chat is an entity that is, like, not present in the conversation. So, like, I was thinking, okay, like, what about y'all? Like, why isn't y'all technically considered the fourth person pronoun? It's because when you say y'all, like, y'all is in the room with you. But when you say chat, the chat is, like, not in the room. And it's even more weirder if you decide to refer to chat outside of a stream. So if you're just, like, saying, like, in normal conversation, being like, chat, am I cooked? Then, like, chat is not with you. Chat is an ethereal being that, like, floats above in this heavens and is always present. So that's why chat is, like, a fourth person pronoun, because it's this being that's sort of floating above all of us, but is never exactly present within the conversation. Chat is the fourth dimension. Exactly. Ether. No, the ether is confirmed. Yeah, so I think there's a whole video on this. But even when I say class, though, right? I think I'm using class as a fourth person pronoun. Because when I say class, I think class can be used as both a third person and a fourth person pronoun. Because, like, if you are in a classroom and you're like class, then class is in the room with you. But if I'm outside of stream and I'm like, class was saying blah blah blah, or class, what is simplified to they third person though? But I feel like chat can't simplify to they, because when you say, oh, I guess if you said like chat said something something something, then you can replace that with they said. But if you say like chat, comma, am I cooked? Like, you're referring to chat. But chat, like, you can't say they, am I cooked? And it also isn't appropriate to say y'all, am I cooked? Because chat is not necessarily in the room with you. Wouldn't chat have the same connotation as everyone? Yeah, but I think you would refer to everyone if an everyone is in the room, right? I think the reason why chat is technically a fourth person pronoun is because, like, you can refer to chat outside of the context of being with chat. Anyways, that was such a nerd tangent. Oh my god. Anyways, unfortunately, I don't have much to say about this confession, but I do have a lot to say about their usage of chat and the ability to use it as a fourth person pronoun. No, chat is always present. Chat is like our generation's version of the ether. Yeah, there were a lot of cursed questions. A lot about like hydrodynamics in a really weird way. Which I hope will be never ever seen again. Thank you. Okay, let me drink some water, and then we will have to do science in under 30 to 40 minutes. So we will have to zoom through these. Orbeez, are you ready? Are you ready to learn? Because I will be the Yapster streamer, and I will speed run through these questions at massive speeds. Are you ready? Have your thinking caps on. Have your brains ready to absorb. Drink some water. Get your bloodstream moving. All right, let's get started. Okay, first question. Do you think people from the future will make fun of us for dark matter as we make fun of people who believed in the ether? My opinion is no. And the reason for that is because there is just so much evidence for dark matter, whether that's observational evidence at both. And when I mean observational evidence, I don't mean like, oh, we're looking and like we're touching dark matter. I'm meaning at both the quantum and the astrophysical scales. There's just so much convincing evidence for dark matter, and it also works really well with our existing cosmological models like lambda CDM. So I think that dark matter is definitely present. I think the question is, what does dark matter look like? And that is sort of the question that a lot of people are uncertain about. I think people might make fun of the ideas we had for dark matter. Like, for example, some people said that dark matter could be primordial black holes, these like baby black holes that exist out in the universe. I think people might make fun of us for that. But I think what was fundamentally humorous about the ether is that it basically does not exist, whereas dark matter does. It's just confusing what the form is. Imagine if this person's watching live. Yeah. Have you read any of the Zeely sequence? Dark matter life forms. I mean, we can't even interact or see dark matter. So mayhaps. Dark matter came from the scientific method while... Yeah, no, exactly. The ether was some sort of weird, like, fever dream type stuff. And there was no exact evidence for it. It was just an idea that was floating out in space. Whereas dark matter has a lot of scientific infrastructure. Okay, next question. What's the relationship between information and entropy to energy and matter? Thermodynamic and Shannon entropy are the same, but how does that information manifest in surface area and not volume? So this was a bit of a complex question, and I had to really go back and like think and even like Google some stuff to try to like formulate a really, I dropped my pen, a really organized answer for this. So, for context, thermodynamic entropy is technically defined as like the number of possible microstates, whereas Shannon entropy is sort of the average, like, information content. So if you think of it like thermodynamic entropy is like, what can a state be? And Shannon entropy, I kind of thought of it just as like relationship with information. So what this question is asking is like, what does information have to do with energy and matter? And I think when you think of information, you're thinking like, oh, like, is this like what I search up on Google and like, oh, that's information? Or like reading a Wikipedia article, is that information? No, I think in physics, information is more so just defined as any sort of like, oh, well, maybe I shouldn't use the word information in the definition, but just any like thing almost that holds like information. How do I define this without using the word itself? Well, anyways, for a bit of context, information has a very close relationship with energy. And the reason for that is because there's this principle called Landauer's principle, which states that erasing a tiny bit of information requires dissipating a little bit of energy as heat. And so if you erase a bit of information, you're basically releasing energy. Maybe somebody can describe information a lot better than whatever I just did. Information is a lack of pattern, at least on the topic of entropy. Ooh, that's a really good definition. Well, I think to answer this question, that relationship, that Landauer's principle that describes that relationship between energy and information helps us describe a minimum energy cost for information, and it links information to thermodynamics. So I think one fundamental issue with this question is that thermodynamic and Shannon entropy aren't exactly the same. And information manifests, how does information manifest in surface area and not volume? Information is considered physical and can be associated with like a specific mass per bit. But this mass of information is not correlated with matter, but is more an indirect effect from energy and using like E equals mc squared. So to clarify, information is closely related with energy. I'm not really sure what they mean by manifesting in surface area and not volume. Yeah, I think it might actually refer to the black hole idea, where there was a claim that the information of a black hole is manifested on the surface of a black hole. That's actually a great question. I would love to learn more about black hole physics. How does information manifest in surface area and not volume? I think I did like 2/3 of this question by describing the relationship between energy and information. Though I will have to get back on the black hole ideas. Black holes are just really unintuitive. I feel like you might think that black holes work a certain way, but they just don't. If anybody has any ideas on the information manifesting in surface area and volume, please let me know. I feel like I don't know enough about this. Yeah, no, it's saying that like the information manifests on the surface area of a black hole. I actually don't know why that is the case. Maybe it might be actually worth searching this up. Surface area black hole information. Here, let's see what we can find. So, okay. So let's see, information of a black hole manifests on its surface. We're Googling this together because I want to learn about this. So yeah, it has to do with the black hole information paradox. So black holes are regions from which nothing can escape. So yes, so any information about matter falling into a black hole is immediately lost. But quantum mechanics states that information can't be destroyed. So what Stephen Hawking suggested was this idea of like Hawking radiation, where black holes like emit radiation. But I guess it doesn't have anything to do with information. Proposes that all information contain... Okay, the holographic principle proposes that all the information contained in a volume of space can be represented as a theory on the boundary of that space. So that means that the information about everything that falls into a black hole is encoded on its event horizon. So that was exactly that's the exact name for the holographic principle. We have zero observational evidence on what a black hole is other than on your shirt. Well, I mean, we have seen black holes. I think the properties of black holes is what's confusing, right? I don't buy the holographic theory. Well, I think there is some context. It's just really quantum and it's really hard to test. These are all ideas that I feel like are part of theoretical physics because they're really just hard to actually test and see if they manifest in real life. Jacob Bekenstein showed that adding a single bit of information to a black hole increases its surface area by 1 Planck unit. So information manifests as surface area. And they say it's holographic theory because that is the behavior of a hologram, where it's a 2D surface. An alternative to this theory says that event horizon has a complex structure that actually stores all the information, not just on its surface. Oh, but the surface itself should be rich with information. So the interior, so to summarize, the interior is like really mysterious and inaccessible. But the surface is where all the information is held. And that might have to do with the holographic theory. The thing about these theories, though, including the holographic theory, is that it's neither like proven science or speculation. It's like somewhere in the middle ground. Because if you want proven science, you should be able to observe it in real life. Of course, it might be backed strongly by existing theories, and these theories might be proven in real life through observations, whether those are quantum theories or astrophysical theories. But the holographic theory itself is not. It's not proven, and it's impossible to prove as well. I think another thing is that it's based off of a foundation of just so much theoretical physics, all of which is also just speculated, and it might be consistent with some observations, but it's just really hard to prove. So yes, this was a great question. Let's move on. And also, feel free, here, let me include the Discord. If you like talking about things like these and want to yap more about black holes and other ideas, go join the physics and engineering channels of the Discord. I want to do more chats like these. I might also hop on voice chat sometime and we could just talk physics, which would be super fun, instead of it being just one-way communication, right? Okay, next question. Oh, so this is more of a general question. I have zero physics background, not even in high school. Where should I start to introduce myself in this field of science? I think even the next question also, from Boxcat, for someone who is not in the space of physics, it seems intimidating and I don't know where to start. What is a good point to start at for someone with only a high school level knowledge of physics? Okay, so to sort of answer the first question, to introduce yourself to physics, you need to start with the basics. I think there's a lot of resources online that just jump straight into the physics of like mechanics and fundamentals and so forth. I think even watching shows like Cosmos sort of can increase your excitement for science. And the reason why I'm suggesting not just jumping straight into all the content material is because I think a really big factor for getting into physics, and honestly the reason why so many people leave physics so early, is because you want to start thinking in a physics way. You start thinking about physics approaches, you start thinking like a physicist, and then it becomes so much easier to sort of digest the material that is being introduced. And so to answer the next question, once you start like sort of getting into physics and sort of thinking about like what areas interest you, what is sort of the narrative of these physics fields, you can start with very like basic foundations. I'd say like it's very typical for students to start with mechanics, which is great because it also gives you an algebraic mathematical foundation to start off on before going into like calculus and more difficult mathematical concepts. I'd say like even if you start with mechanics, it's really important to sort of play with practical application and examples. Don't get stuck on Cosmos, most of it outdated. Wait, I have to disagree with that. I think, okay, maybe the old Cosmos book I think is probably outdated by now, but I think Neil deGrasse Tyson's show from Cosmos, which I think was about 2012, was honestly really, really good. And I feel like it was just, maybe some of the information is outdated now, but visually it is a really good way of connecting what you might read in a research paper with actual like observing things. Like for example, I think one of the episodes they like go and like see a tardigrade, and like versus maybe like reading about like tardigrades in a research paper. It really brings a visual element to learning about the topics. I'm not a big fan of Neil deGrasse Tyson, but his Cosmos show was cool. Yeah, no, I really loved Cosmos. I think that's what single-handedly got me really interested in astrophysics. So I think also to learn physics, I think you should also look for physics books for beginners or for the high school level. And there's also a lot of educational channels, like Crash Course Physics is good. Khan Academy, I think, is really, really good. I think they're really clear and concise and beginner friendly. I think Khan Academy also has a lot of interactive exercises. So there's a lot of online resources. Science Edutainment is the entry drug to studying advanced calculus. Honestly, I feel like science edutainment is like a gateway science, or like even just a gateway to science. And the reason why I say that is because you're starting to think about these concepts and you're getting excited about these concepts. And then naturally you want to learn more, right? So you then start searching things up, and then you're learning, and then you're reading research papers, and even reading research papers is a lot of practice. So it really is a gateway. So I'd say like start small. I think if you try to start big, you can easily get burnt out or feel overwhelmed with a lot of information. But start small and start practicing, and yeah. And ask questions, which is really, really important. Okay, next question. Okay, this is going to take a bit of time. Is 1 + 1 really 2? Okay, so I took a lot of notes on this. Because at first I was like, yeah, duh, it's 2. But then I realized, I remember that there was just one research paper that was done on this. It was about like 360 pages long. And I actually got a chance to sort of look through this research paper. So, quick answer is yes. But the reason why this question is always brought up and is like a bit of a joke is because the proof behind 1 + 1 is equal to 2 is really nuanced. Because you have to start thinking about like, what is 1, what is plus, what is equals, and what is 2, right? You have to like define, you need a strong logical foundation. So this 360 page research paper, which I highly recommend you read, by the way. Hold up. It's called like Principia Mathematica. I think you should start by reading this article. It goes really in depth, and it might fly over your head. Yeah, how do we know that the second one is the same as the first one? Exactly. So this research paper like goes into defining like what we mean by like 1 and 2, and it defines like the concepts of like addition and equality. And even like the most basic arithmetic facts. I think you should read this Principia Mathematica because it sort of like builds up the logical foundations of mathematics itself. And only after that does it start going into proving 1 + 1 = 2. And to summarize this paper in a layperson kind of way, it defines like 1 as the successor of 0. It defines 2 as the successor of 1. And it defines addition by saying like n plus 0 is equal to n. And n plus the successor of another number z is the successor of like n plus z. So it basically like describes numbers as their successors. And so if you say 1 plus 1 is equal to 2, what you're actually saying is like 1 plus the successor of 0 is equal to the successor of like parenthesis 1 plus 0, which is the successor of 1, which is equal to 2. Here, let me just like quickly like type out what I just said. So 1 plus 1 is equal to 1 plus the successor of 0, which is equal to the successor of like 1 plus 0. Oh my god. Successor of 1, which is equal to 2. So that's basically what this paper describes. Yeah, no, step 1 was definitely defined algebra. It was really crazy. But I think that's sort of basically the main summary of the paper, that at least what I took away from it, from skimming it. Please note that I'm also not a math academia person. So yeah, that's basically the reason why 1 plus 1 is equal to 2. Super, super cool stuff. Okay, we have very little time, so we got a speed run. Next question. What's beyond the edge of the observable universe? So I have to say that there's a few things that I want to point out about this question. First, there's no edge of the universe. And second, there's like, okay. So the observable universe is defined as like the portion of universe that we can see from Earth, limited by the age of the universe, limited by the speed of light, because the light from the furthest regions of the universe have to reach us. And it's about like, it's super wide. So when you say what's beyond the edge of the observable universe, it's just simply more universe. It's just that the light beyond that hasn't been able to reach us. And there's no like physical boundary that just stops us from going past the observable universe. It's just that that light hasn't reached us yet. The Great Attractor, yes. So, yeah, I think there's some theories saying that like the universe might curve back on itself and so forth. So, yeah, I have to say that's the answer to my question. It's just simply more universe, and there's really no edge. It's just limited by how far we can see. Okay, I did research on the interacting galaxy ARP-256 and its star formation in college a couple years back. Can you talk about how pretty it is, how it's incredible we can see it, and how we use RF and Doppler shift to map the moving of the cosmos? RF is radio frequencies, I think. I just want to hear someone else talk about it and tell everyone how cool this galaxy is. So I actually Googled the galaxy itself. Isn't that beautiful? I have to say that it's really easy to nerd about galaxies just because they're just so spectacular. So what exactly is going on here? So this is actually a system consisting of 2 spiral galaxies that are merging with one another. And it's actually the early stages. And you can see these like long tails like flailing out. What those are gravitational forces from the interaction just basically pushing and stretching out these galaxies. And these blue regions that you can see are intense star formation triggered by the collision itself, where gas clouds basically merge and are gravitationally like condensed, which can then become hot and dense enough to form stars. So to sort of add on to this like Doppler radio telescope idea that was part of the second part of the question, radio telescopes are really, really important for us. And the reason for that is because they can help detect neutral hydrogen gas. And if we are able to detect this gas, we are able to look at the distribution and motion of these material in and around the galaxies. And the Doppler effect is really useful because when things are moving towards us, they look more blue. When things are moving away from us, they look more red. It's similar to how when you stand along the side of the road and you hear an ambulance and it's going closer to you, it starts to become more high-pitched. And then when it's moving away, it goes like, wee, 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 and it goes like really low. That is basically the essence of Doppler effect. It's that we're doing for these humongous galaxies. And by looking at how red or blue the different regions of the galaxies are, we can actually map a 3-dimensional structure of this interaction and see how will it evolve over time, how will the materials shift around, and what's even cooler is these are incredibly relevant for us to understand our upcoming collision with the Andromeda galaxy itself. So this is just a super, super cool application of these galaxies, and it's really cool what kind of tools we have to better understand these. Yeah, no, exactly. You can see how like the top left is being like stretched out. If you look at the bottom right too, you can see like these like little like ripples that are happening. That's because of the push and pull that's happening within this galactic system. Okay, anyways, that is me nerding about this system. Thank you so much, Handful of Sharks. Really cool to also see a beautiful photo of galaxies. Next question. I don't really understand emergence as a concept. For example, why does water make you wet, but a single molecule of H2O doesn't? This is from Kurisu. So, I think like a single molecule of H2O has really different properties from many molecules of H2O. Like, for example, a single molecule has like chemical properties, it forms bonds with other molecules, it has a particular shape and size, but a large collection of molecules has new properties like being wet, surface tension, fluidity. What? Wait, I have to pause real quick. You have a tattoo of ARP-256 on your forearm? That is so sick. That is so cool. If I were to get a tattoo, I would get a tattoo of a galaxy as well. I actually saw somebody recently, one of my friends actually, she, as a birthday gift, got a forearm-sized tattoo of the Golden Record Voyager, like, location map. How do I explain this? It's like where the quasars are located. If you look up like Golden Record cover pulsar map, she got a tattoo of that stretching across her forearm, and it looked spectacular. I think quite a few people actually have those as tattoos. I think if I'm gonna get a tattoo, I might get that. Yeah, no, Sharkman, if you don't mind, of course, it would be so cool to see it, and that would look spectacular. That is so cool. Please put it into the Discord. Oh my god. Part of it went into the elbow. I really want a tattoo, but I feel like I have no tattoos actually. So I heard that the first one, you have to really make sure that you have a good tattoo artist and you communicate well with the artist, and yeah. And I also heard that once you get your first tattoo, you're more inclined to get your second and third. So, maybe I should get a tattoo. Orbeez, what do you guys think? Should I get a Voyager tattoo? Would that be cool? Okay, to finish off this question. So, a single H2O molecule cannot produce effects like fluidity, surface tension, and more. But it's only when many molecules combined come together and interact that these like emergent properties of wetness appear. So this idea of emergence is saying that like as an individual has different properties from many molecules together. So that's just my opinion on emergence. I'll have to check out this free will Kyrgyzstan video. That sounds really cool. Get a full sleeve with nothing but nerd symbols and equations. I thought it would be really funny to get the Schrodinger's equation on my arm, but I felt like that would be too nerdy. Just have like a whole reference sheet on your arm in like 2-point font. Get a tattoo of the Orbeez and a handful of sharks. I'm totally not biased. I think it would be funny to get the tattoo of Orbeez. But I feel like also just getting a space tattoo would be super sick. Oh yeah, no, tattoos that touch bone are super painful. Okay, so that's all about emergence. Next question. What is the airspeed velocity of an unladen swallow? So at first I was really confused about this question, but apparently it's a reference to Monty Python and the Holy Grail, which I've watched like once many years ago. So, doing some Googling, the average cruising airspeed velocity of an unladen European swallow is about 11 meters per second. And for an African swallow, estimates may vary, but it can reach about 11 to 14 meters per second. So I think the answer is about 11 to 14 meters per second. So, yeah, there's the answer. Thank you so much for this funny reference. I was really confused at first. Next question. Asking this for my physics test coming up soon. Explain force vectors, especially resultant vectors, resulting from angles and force vectors. Sorry once again. No need to apologize because we will do a quick crash course into force vectors. So, what is a force vector? A force vector has both magnitude and direction, and it's represented by an arrow, which has the length of the arrow representing the magnitude and the direction representing the direction that the arrow is pointing at. So, for us to do resultant vectors, what that means is basically combining multiple forces. So if you have a vector arrow, that can be broken down into its horizontal and vertical components. So if you arrow here, you can measure how long is it along the x-axis and how long is it along the y-axis. And this information is really important because if we want to combine many vectors together, what you can do instead is actually just combine all of the horizontal components and all of the vertical components and calculate the angle using a formula. So how might you do that? You might be wondering. So let's say that you have many different forces happening at once. You can combine all the horizontal aspects and the vertical aspects. Then you get a gigantic arrow with a specific width and a specific height and a specific angle or direction. You can find the magnitude or the length of that arrow by basically doing square root of the horizontal component squared plus the vertical component squared. And you can find the direction by taking the inverse tangent between the vertical aspect of the arrow and the horizontal aspect of the arrow. So basically, it's a way to combine vectors together. So yeah, hopefully that's helpful. It's really useful because vectors are so flexible and their properties make it so much easier for us to understand multiple forces all at once. Like if you have 100 forces, that can basically just be described as a single humongous arrow with a specific direction, which makes things so much easier. Oh, Fleeting Twilight, that was your question on Reddit? Yes. Okay, next question. Oh, we gotta speed run through these. What is your favorite existential dread of the cosmos? Okay, these are all amazing examples, which I'll also talk about more in a bit. But I think my favorite existential dread has to be the, what's it called? The vacuum decay. It's this idea that our universe may not be in its true ground state. And so, because of quantum tunneling or because of a black hole explosion or a major event, there might be a point where a part of the universe starts entering its true ground state. And this would start out as a bubble that would expand at the speed of light. And within that bubble would be brand new physics. Basically, anything that the bubble touches would be eviscerated because it no longer obeys the same laws of physics. And this bubble expands at the speed of light, which means that we wouldn't be able to see it because by the time we see it, it would have also arrived. So if we were to suddenly be absorbed by this vacuum decay bubble, we would literally be like sitting here and then bam, lights out, completely gone. It would be like the pressure implosion in Ocean Gate, except it's the entire universe. Yes, exactly. It's when the Orbeez abandoned her for the more massive star. No, you Orbeez would never abandon me, right? I have to say that is not an existential dread of the cosmos because I'm confident in my ability to encapsulate your mind, to enrapture your minds. Yeah, no, this whole idea of a vacuum decay bubble is so scary because it could literally be approaching us right now and we would not even know it. But don't worry. I think recent calculations show that, like, from probability, a vacuum decay bubble would take about, like, 10 to the 100 years to emerge, which is very long from the actual age of the universe. But who knows? Probability may not be in our favor, and we might just suddenly vanish. Next question. How will space travel affect weaponry such as small arms in the future of warfare? If this is outside your expertise, what is your favorite color? Well, I can answer both. So, first off, my favorite color, which is shown here, is this like maroon red color that is part of the Pokemon known as Zoroark. I actually modeled my hair color based off of this color, if you can kind of see the tint a little bit. So my favorite color is like reddish maroon. So, space travel affecting weaponry. I think there's a lot of questions about space-based like missile defense systems and spy satellites, just like the launch we saw this morning. But I think there's also the potential for brand new weapons. So there's this idea known as Kessler syndrome, which is saying that at some point we might reach a threshold where there is just so much fast moving space debris that all of a sudden this space debris would collide with one another, causing a giant chain reaction of even more space debris. And then before you know it, we would literally be surrounded by so much fast moving space debris that we would not be able to escape the universe. I mean, the planet. And so one of the ideas that I was actually thinking about, okay, this sounds really suspicious. I was not thinking about this idea. I was just thinking about the possibility of this idea, which is that a rogue nation, as part of a threat, or maybe to wreak havoc on society, could develop a Kessler syndrome weapon. What that would be is basically like a rocket ship that would explode, releasing a ton of tiny, small space debris, starting this chain reaction prematurely. And then this chain reaction would spread all throughout our entire atmosphere. And then there would be so much small debris in our atmosphere that we would be trapped. So basically, a single rogue nation could basically end the space age, could end our ability to leave this planet. So I think space travel, there's a lot of implications for like spy satellites and whatever. But if you're talking about existential dread, I think that's one of the ways that our civilization could effectively end. Or it's just Boeing with their exploding satellites. Honestly, it can even be just like nations. I know like back in 2007, China conducted a missile test and blew up a satellite. And that was like the single largest creation of space debris. I think it increased space debris by almost 50%. And if you look at a chart of like space debris like over time, you can literally see like this peak that happened during the here, let me just paste this. If you go to that link, you can literally see the Feng-Yun anti-satellite test, and just like the number of space debris just like surged because of that. And it's a demonstration of how a single nation or even a single test can set us back so far when it comes to space. Have you ever heard of kinetic bombardment? I have actually not heard of kinetic bombardment. I feel like I may have heard tangentially. Is the type of act of attacking a planetary surface with an inert kinetical... Yeah, no, basically you could just like drop something. It's absolutely terrifying. I think if there's one thing we need to learn from this is that we need a lot more regulations on space. Okay. Rods from God. Okay. I think I don't have that much time left, so we should definitely speed run through these. Project West 4, but bigger. The US has also shot down satellites. Yeah, no, this is a huge issue. Dealing with old satellites has been a big issue, but I think we have to find ways to navigate and also regulate space debris. Next question. What is your favorite field of subject for astronomy? Okay, I think I may have mentioned this earlier, but I do like computational astrophysics, probably specifically galaxies. I think maybe one fun fact is that the James Webb Space Telescope has been looking and exploring these galaxies, and what they've been finding are these galaxies that are so massive that they shouldn't be able to exist, according to our definitions of the universe. What that means is that these early galaxies are much larger than we anticipated, and we don't know why it happens. And so one of the questions being explored at James Webb is sort of answering why that happens. So I think that's just one of the more active areas of research. It also involves studying like how galaxies die, which is a super interesting aspect. Takes way too long to reach its target. Is a missile that shoots out other things with space with a kinetic warhead. So is it in space? Is SM-3 in space? Or is this something like an Iron Dome, like the Iron Dome, where it like is able to see it and like shoot it down? Okay. What is the most fascinating mystery about the universe to you? Nameless one. I have to say it does have to be the vacuum decay bubble, if that's like approaching us. I think this idea of like why early galaxies are much larger than it appears is also a good question. Okay, I think if there's one fascinating mystery, it's like, what is dark matter? What is it made of? And how can we possibly detect it? I think dark matter is one of the biggest mysteries and is really fascinating. I think it's also really interesting because it connects so many different areas of physics. I mean, you can explore it from like the quantum level, like colliding particles together. You can look at it from a galaxy level or even a galaxy cluster level, seeing how these like massive structures are able to interact. It's like truly the most like interdisciplinary question that we have in physics at the present. Oh my god, what is your opinion on the theory of loop quantum cosmology? I know that it's improbable and there are many more likely theories. Okay, so what is the loop quantum cosmology theory? So I jotted down some notes here actually because I didn't know much about it. So this theory aims to resolve classical singularities such as the Big Bang and the Big Crunch. So basically in classical general relativity, we say that singularities, like maybe the inside of a black hole or the start of the universe, are points, physical points where the universe becomes infinite. But the loop quantum cosmology theory actually sort of like smoothens out these figures by saying that space is not like continuous, but is made up of these like loops. And these loops like redefine our traditional notions of space and time. And so one of the most interesting ideas is this concept of big bounce. Instead of a singular beginning for the Big Bang, it says that the universe actually is bouncing from a previous contracting phase. So there wasn't a singularity, but more like a loop period. So just a way to combine cosmology and quantum gravity. There is a PBS space-time video that I highly recommend you watch. Oh no. Oh, well, you can see my wallpaper. It's actually a piece of artwork that was painted by Eggy. Loop quantum cosmology. PBS space-time. I highly recommend that you watch this video. Please. Yeah, no. Thank you, Eggy. Yeah, no, it's been my Chrome tab page, so whenever I open my Chrome, I can see it. Here, I am running very, very late, but let's finish up these questions. I don't really know much about loop quantum cosmology other than the fact that it suggests that there could be many, many universes instead of like a Big Bang. It may have just been like the creation of another universe. Like, it's just fluctuating? Yeah, mayhaps. Actually, here, might be something we should chat about on Discord, because I feel like this is something that even I don't know much about. Whoever submitted this question, too, if you have any thoughts, that would be great. Okay, next question. If you have to explain Kirchhoff's law to a 5-year-old, how would you do it? So, I actually, like, did a brief explanation about this before in the past. So I'm just gonna use the same analogy. So the analogy that I like to use are like playing with cars on a racetrack. So like, so let's say that you have toy cars on a racetrack. So at any point where the track splits, the number of cars going in must like equal the number of cars coming out. You can't get rid of any cars. So like if you say like 3 cars enter a split in the track and then 2 cars go one way and then 1 car goes the other way, then the 3 cars going in is equal to 2 plus 1 is equal to out. The 1 out. No. 2 plus 1 is equal to 3 cars coming out. So that's for the current law. And then for the voltage law, I thought that like when you drive around the whole track, you end up at the same height that you've started. So you can visualize like a battery being like sort of a powered ramp where you can like basically push the cars up the ramp, and at the end of the whole track your car will be at the base just as where it has started. So the cars are like the current, the track is like the wires, and the whole idea of also using cars is to demonstrate that energy cannot be created or destroyed, and we can use hills to sort of represent like potential, voltage potential, except like the hills in this case like represent batteries or other sources of like electric energy. So I think that's a really interesting way of like explaining Kirchhoff's laws. Just because like you can basically draw connections between like voltage potential and gravitational potential and using cars, which is really appealing to a 5-year-old, right? So yeah. Okay, next question. Who would win in a straight up fist fight, Isaac Newton or Nikola Tesla? From Miles David. Let's actually do a poll in the chat. I personally think that like Newton would win. I think Newton also looks a bit more buff in his photos. Maybe this is just a hot take. I also feel like Newton was a pretty cool lad. Also, Newton studied like mechanics, so he would know like how that would work, right? Wow, it really is split. Okay, while that poll is going, let's go on to the next question. Oh my god. So I put this question here, but Trickhole, whoever this person is, I have to admit that this is not my area of expertise, but I did my best to try to gather answers. So from my Google searching, a low voltage single speed 3-phase induction motor is a very specific type of motor. It has a lot of different features, like it operates below 1000 volts. It has a speed determined by the number of poles and supply frequency. It has a 3-phase AC power supply. And it, as a result, it has like 3-phase like windings embedded in these like slots. But that can be like a lot of details. I think in general, one thing to know about this is like there is a rotating magnetic field that is created within the stator. And then this rotating magnetic field induces currents in the rotor. So it also creates a magnetic field. So it's like basically an interaction between this like rotating magnetic field and the induced currents, which then produces the torque for this motor. And it's really high efficiency. And this torque is usually starts out really high, which is advantageous. I'm pretty sure this is not the best description, and I am happy to also answer questions offline, but yeah, this is my best. I'm trying my best. And then why do we need to change the bearings after shaft shortening and rebalance? So when a motor shaft is shortened, basically shortening the shaft like changes the shaft's like mass distribution and its diameter. And this is important because it can change the distribution of the load along the shaft. And what the load can be is like, it can be like what we're testing on, it can be what the tool is being used, and so forth. So basically, shortening the shaft changes the mass and the diameter, which then helps us distribute the use and load of the of the tool, of the motor. And for rebalancing, I have to say that this is not my area of expertise, but from what I was able to gather, it changes like the mass distribution of the rotor assembly. And by shortening the shaft, you have to be careful when rebalancing, because if the original rotor was balanced, removing more material might lead to it being not balanced. And that can lead to things like excessive vibration. It can lead to like bearing failure, reduced efficiency, all these bad things. So after shaft shortening, it's important to rebalance the rotor. I did my best to try to summarize like what I could find online. But if you have found the answer, or if you have any insights, please do let me know. Okay, before we move on, let's take a look at the poll. Tesla? Orbeez? You guys are all in a disagreeing mindset today. Okay, Tesla does have a really sick mustache though. That is true. Okay, Orbeez. We'll stick with that. We'll stick with that. Okay, next question. How likely is that there are alternative universes out there? And if there are multiple, what is the most likely way that a person could travel to different universes? So, these are all theorized. So, it's really hard to say if there are alternative universes out there. I think if there were multiple, one possible idea is like wormholes, which are like tunnels, which would allow us to access other universes. This like idea comes from like Einstein, where you could do connect black holes to white holes, and those could actually potentially be in other universes. Another idea is like quantum entanglement, where two particles that are entangled with each other could transfer information or even travel between the two. But I have to admit that all of these ideas are still theoretical. We don't know if there are alternative universes, and even if there are multiple, traveling to them is also very theorized. Didn't Newton get into fights all the time? Maybe back in those eras. See, this is why Newton should have won. Z is going 0 for 2 in the polls. You orbeez are just cruel. What can I do? Okay. This is the second to last question? Third to last question? Okay. Heat death, big rip, or big crunch from Kagemoto. These are all different types of ways that the universe can die. So what do each of these mean, right? First off is the heat death, also known as the big freeze. So what this means is that the universe will keep on expanding until it reaches a state of maximum entropy. And what that means is that all the energy is so evenly distributed. Basically, everything has reached equilibrium, and there's no thermodynamic free energy. So that means that stars will burn out, galaxies will drift apart, the universe will be sort of a cold, dark place where nothing can occur. No life, no activity. And the scary part is that this is currently being supported by observations of the universe. Because the universe is accelerating expansion due to dark energy. The big rip is this idea that the expansion of the universe will increase even more, and instead of, cooling out and entropy settling down, it actually just tears apart all matter. It tears apart galaxies, stars, planets, and then eventually atoms and molecules. And if dark energy increases in strength over time, it could lead to this. But I think the good news is that from my understanding, there hasn't been any demonstration of these specific properties of dark energy. So maybe this second one will be okay. And finally is the big crunch. It's this idea that the universe will eventually reverse, and it will cause to collapse back into a hot, dense state. And then maybe another universe may appear. But I think as of now, the dark energy models are showing that the universe's acceleration will continue. So out of all of these, I think heat death is the most likely. Sonoda asks, which do you prefer? I think heat death is probably my favorite, just because I feel like the big rip would be scary. Big crunch would be horrific. I think heat death would go on for quite some time, and maybe there would be a way for us to I guess we would run out of free energy in the universe. But I think it would be the longest period of time. And hopefully by then, humanity has other things to worry about. Or maybe we found a way to go into a multiverse or something. Yeah, heat death is going to be 10 to the 107 years. Oh no. By then, the vacuum decay bubble might be rapidly approaching our location. Because a vacuum decay bubble may start in 10 to the 100 years. Okay, but I would not want to die through a vacuum decay bubble because it would just be lights out. That's absolutely horrific to me. Okay. Second to last question. With all the current ongoings in theoretical physics, astrophysics, and space, do you believe dark matter is a hypothesis worth keeping around? I think this is really similar to a previous question we had, maybe the first question in this category. In the meantime, I'm actually curious, which universe death do you guys prefer? Heat death, big rip, or big crunch? Honestly, seeing how well my polls have been going today, I'm sure that you guys will choose the one that I did not choose. With all the current ongoings, okay, so again, I think dark matter is consistent. It's consistent across scales, quantum and astrophysical. It's consistent with observational evidence. It's compatible with our existing models of dark energy and the universe's acceleration. So I think it is a hypothesis worth keeping around. I think as I mentioned earlier, the big question is, what is dark matter made of and how can we detect it? I think we've tried so many avenues of trying to detect dark matter, some of which have worked and some of which haven't. And I think we just need to be really cautious about where we spend our resources. There might be certain avenues that work better than others. And I think in our scientific community, we're trying to find what those avenues might be. And this is the final question, which is perfect timing because I am running a little bit over time. It's okay. It's okay. Why did this year's Nobel Prize in Physics go to computer sciences working in AI? Is CS a field of physics or am I misunderstanding their achievements? This is actually a great question because it's an idea that I think we bounced around in the Discord. It's an idea that I've been thinking about and talking about with my colleagues and so forth. So I read basically what the discovery was, and to summarize, the research bridged physics, computer science, and neuroscience. And it was work on artificial neural networks, and it drew inspiration from applied concepts like statistical physics and thermodynamics. So, in English, they used physics to develop machine learning techniques. And their work involved concepts like minimizing energy and statistical mechanics, which are rooted in physics. So, I think it's just a really interesting example of how physics and AI or machine learning can easily be connected. I think a lot of physicists do argue that this work belongs more to computer science, and maybe it would have been more appropriate for the Turing Prize, which is like the computer science version of the Nobel Prize. I think one of the opinions that I have is that there have been some people that I believe deserve the Nobel Prize posthumously. That includes like Jocelyn Bell, who did not win the Nobel Prize, but her male advisor did, which was a huge controversy. Includes people like Vera Rubin, who I think also deserves a Nobel Prize. So I feel like if they didn't really have people, they could have easily given it to someone else. But the truth is that the Nobel Prize in Physics did go to Hopfield and Hinton, and there's really no going back on that. And I think, if anything, we need to start considering the interdisciplinary nature of research and see their work as like an expansion of what constitutes physics. So at the end of the day, this decision does reflect how AI and machine learning are growing across scientific disciplines. And I think the definition of physics and even individual STEM fields are becoming more blurred as time continues. I think this is also a consequence of like having resources out on the internet. People don't just interact within their field anymore. They interact with all sorts of different communities through email, through messaging, through reading research papers online. And so these interdisciplinary approaches, I think, is a new trend and is something that should be welcomed and considered. Maybe you guys have better opinions. Maybe I should do a poll right before I leave. But let's see. By the logic, financial engineering is a branch of physics. I think financial engineering is a bit of a stretch. I think this one was also a little bit of a stretch, but they did use like physics aspects like statistical mechanics. There isn't a category for computer science and engineering. Exactly. A few of the most recent biology floating prizes are also heavily comp sci. I think this is like a weird combination of biophysics and comp sci, which is why it's been under so much scrutiny. Nobel's effectively losing that prestige outside of physics, and this may have its impact on its prestige within physics as well. Yes, that's true, but I feel like the Nobel Prize in some ways has also been quite controversial. Whether it's like not awarding the right people the Nobel Prize, like for example, like Jocelyn Bell did not win the Nobel Prize, but she did win like the Breakthrough Prize, which is also incredibly prestigious. An expansion of what constitutes physics, the most physicist statement. Chat, you're calling me out. No. Like Nobel Prize at the moment is just, oh, well, I actually think the Nobel Peace Prize this year was really profound. It was for a group of survivors of the Hiroshima and Nagasaki tragedy. And maybe I'm biased because I actually got a chance to talk to a survivor who I believe was part of this group this summer when I was visiting Japan. But I feel like it is a really important message. And I also think that it was good that it was awarded to a group. I feel like for the Peace Prize, having it awarded to an individual, to me, at least seems a little bit odd. And I also feel like as a group, like, there's a lot of, like, institutional history for them to continue what they're working on. Whereas with an individual, once that person retires or passes away, their contributions to peace effectively end. Whereas with an institution, there are just so many more generations and opportunities for people to learn and get involved, which is why I feel like the Peace Prize this year was much more profound. For my part, CS is more math, but maybe they did a ton of computer engineering work for the software project. Only giving prizes to experimental physics and not the theory behind it. Yes, no, that is also another idea that I've been hearing. Yeah, no, Watson and Crick winning one for DNA structure was some BS. I think also Rosalind Franklin, I believe, also deserved the Nobel Prize because effectively her measurements, her experiments were what led to the discovery of the DNA structure. Alright, goodbye, Boxcat. Actually, along those lines, I think we should bring this stream to a close. I've unfortunately been running over time. I was planning to end this stream at 11:30 a.m. PST, and it's currently 55. So, these are all great ideas. Let's see. Heat Death won! Honestly, there's no better way to end this stream with a victory for Z. A success. Wait, success, but with a Z is like success? Kind of sounds like Zuck from like Mark Zuckerberg. Issue was Rosalind Franklin was long dead. Yeah, no. But I think Nobel Prizes can be awarded after death. Yeah, no, these are all... I feel like this Nobel Prize in particular addressed a lot of questions about... Yeah. It started a lot of questions about how to pursue physics and what the field of physics is going to look like in a few years. Oh, you have to be alive for the Nobel Prize? Well, then it's not too late to give it to Jocelyn Bell. I'm gonna stay salty about this forever, honestly. You gotta be alive when it's announced. Oh, I see. Oh, these are all great ideas. Okay, Orbeez. I think this is going to be the end of the stream. But thank you all so much. We went through like 40 questions in like an hour 30. And we got a chance to watch a literal launch. Which was so cool. I'm honestly so glad with the way this stream came out. And this Saturday, I'm planning to do a hand cam Lego building stream where we'll literally be able to build a Syzygy Lego. See, now I have to go to class. Thanks for the research and talking through everything. Yes, I hope this was really fun. It was really fast, but I feel like that also made it fun. I hope it was at least accessible. And the VOD will be up later today and with timestamps. So if you ever want to go back and hear another explanation or put it on like 0.5 speed, please go do so. Thank you, Orbeez, so much. And yes, I shall see you guys in the next one. Bye-bye. 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 See you later. Stay hydrated. Take some time for all this information to digest. Take care. See you all later. Thank you so much for coming. Bye-bye. Bye-bye.